Morning, my name is Stephanie Smith and welcome to Risk Management Professionals webinar series. Our producers Nick and Vincent are here in the background to help run this program this morning, and will be assisting us with taking questions and collecting those for the end of the webinar. We're using GoToWebinar. Please, if you experience any technical difficulties, use the number 877-532-0806. It's on your screen right now and on the printouts that were provided in PDF form. We have staff available that can help with some technical difficulties, or at least get our attention if we're having any technical difficulties globally. In addition, you have a dialog box for questions. Please submit them along the presentation if you feel comfortable. We'll collect those all at the end and address those together on the last slide. This webinar series is part of our ongoing outreach program, and our core competencies and expertise reside in EPA RMP, OSHA PSM, CalARP, and SEMS program development. We do HAZOP and LOPA studies, as well as other hazard identification techniques, and a variety of other process safety and regulatory standards efforts in dealing with those regulations. I'm Stephanie Smith. Sara will be up about halfway through this presentation, and we can go ahead and get started. The first slide is just a brief overview of our key services. Again, they're in your printouts. Feel free to peruse later along with our contact information. And I wanted to start with a summary of general IIAR2 information, go over a little bit of parts 1 through 3 of this series that we've done previously, although most of that is residing in the definitions, and then continue on into chapters 11 through 14 of the IIAR2 standard. IIAR2 was designed, or was written for the safe design of closed circuit ammonia refrigeration systems. Please remember, this was written for the design of new systems, not existing, but since there's no formal RAGAGEP standard from IIAR yet, although they're coming out with that, I believe in the next year as a draft form for public review, we'll be looking at this from a perspective of how can we apply these standards to existing systems for RAGAGEP efforts. So if equipment is being redesigned or changed out, or if there are any improvements along the way that can be applied to the system to make it inherently safer, that's the kind of perspective we're also bringing with this presentation. Part of the purpose of IIAR2 was to align itself with the ASHRAE Standard 15, NFPA Code, Uniform Mechanical Code, International Mechanical Code, and International Fire Code. The part 4 that we'll be doing today, we'll discuss chapters 11 through 14. Previous chapters are in previous parts of this series, and we're looking at probably 2 to 3 more parts to cover the rest of the standards, and we kind of have been playing that casually as we go and just make sure we get all the information in here. Again, IIAR 9, which is the new RAGAGEP standard that's coming out, is in progress and will be specifically published for RAGAGEP on existing facilities. That, I believe, is projected to be in a public review status in the next year, but I don't know for certain. I think they're still a little ways out. We just went through a review for the other standards that have already been published, whether it be the typical annual or the new publication. Getting into the definitions, some are reminders from past parts of this series and some are new. Maximum allowable working pressure is a maximum pressure permissible in the vessel during normal operations at the design temperature. This is information provided by the manufacturer, tested and certified for the equipment. Minimum design metal temperature is the lowest temperature permitted for the metallurgy of a vessel, and this comes in with the fabrication and the composition of the metal itself. Again, it comes from the manufacturer and should be part of the information that comes during purchase. Package systems are prefabricated or pre-assembled units. This could be anything from a compressor package to a vessel package or pump package. So they come in a number of different varieties and ways. seems to be more common now, makes it a little bit easier to install, and we'll be talking a little bit about package systems in this presentation. Piping in general concerns any interconnecting parts of a closed circuit refrigeration system. This could be pipe flanges, bolting, gaskets, valves, fittings, etc. Anything that can be used for a purpose of mixing, separating, snubbing, distributing, metering or controlling flow, pipe hangers, support fixtures, and structural attachments. So anything related to piping, valving, or interconnecting big pieces of equipment, by definition in the standard considered piping. Pressure vessels are exactly that. They operate under pressure and follow the ASME boiler and pressure vessel code. That would be section 8 division 1 of that code, and those exceptions would be for compressors, pumps, controls, condenser coils, etc. They're listed there. So there are some exceptions for the pressure vessel, but in general we're talking about anything that's operating under pressure. Readily accessible, we've had this before, where a piece of equipment or a pipe or a valve must be able to be reached easily, so not using any ladders, not climbing any stairs. It needs to be basically you can walk right up to it and it'll be available to you to access and do whatever you need to do, whether it be an emergency or normal operations. Shall and shall not and should not are very common terms obviously used in these codes. I always like to throw them in here. Shall not is a mandatory provision. Should not is optional but recommended. Again, there is a distinction between the two, and they're used very commonly and widely in these codes. Tight construction is a solid construction where any openings are closed or sealed and would not allow liquid, moisture, air, or vapor to seep through the joint or the area of contact. Ultimate strength is the capacity for the material structure to withstand loads that tend to elongate. So this would be part of the equipment ID information coming from the manufacturer. It kind of ties into the metallurgy and composition of the materials. So we'll jump in right to chapter 11, discusses evaporators. This chapter is applied to evaporator coils and microchannel heat exchangers, as well as other types of evaporators. There are 5 types of evaporators covered specifically in this code. We'll get into some detail. I'll try not to just read the code to you. There are a few points that I want to make where it will sound like I'm reading the code. It's because I am. It's important. But in general, just trying to just elaborate on what's written on the slides and kind of keep moving it along, because I figure everyone can read the codes for themselves if they need more detail. The design code for forced air evaporator coils includes the minimum design pressure from section 5.5. That was covered in part 1, where we discussed what the design pressure requirements are for different types of equipment. That's the general information in the front in chapter 5. The ultimate strength requirements are from section 5.13.2, again from part 1, and those would be listed in that general chapter for all equipment. Hydrostatic overpressure protection is discussed in section 15.6, which we will not get to today, but we will cover in the next part. It's the next chapter that we have to do. So we'll save that discussion for later, but just be aware that evaporators need overpressure protection. Fan speeds are from the manufacturer recommendation, so that comes right from the designer and the manufacturer. And pressure vessels are in chapter 12, which Sara will cover in this presentation as well. And that will elaborate on what the requirements are for anything that would be considered a pressure vessel within the evaporator or connected to the evaporator. For procedures and testing, and we'll see this general requirement a lot, that testing for strength to be a minimum of 1.1 times the design pressure. Also subsequently leak tested and proven tight at least at design pressure. And that's a very common theme for all of the chapters we're discussing today. You'll see that requirement or something more stringent listed for each piece of equipment. Oh, actually I forgot one note too. In terms of hydrostatic overpressure protection, In general, it's required where refrigerant coil inlet and outlet connections can be automatically isolated. And again, that'll be something a little repetitive for each type of evaporator, but in general, we'll cover a little bit different aspect of that. In addition, for forced air evaporators, equipment identification information is important. Includes manufacturer name, various other information that will be just attributed to the equipment serial number, model number. The direction of fan rotation is important if it's supplied and if it's there. The electric information for motor size, the heater ratings, and electric supply information should also be recorded somewhere. For installation, always make sure that there's unobstructed airflow in the inlet-outlet areas per manufacturer's recommendations. They're really the experts on their equipment. They know how they've designed it, so always follow their recommendation or something more conservative than that. There also should be a means for preventing freezing inside the condensate drain lines, especially where the lines are exposed to freezing temperatures. Some examples of this would be slope to drain, heat tracing, insulation, or cleanouts. So there are some options there. It's not limited to those options, but that's what the code suggests to use. Also, P-traps are required in the drain line for each evaporator. This is to prevent warm air from migrating to the condensate drain pan connections and creating frost. So again, a lot of protections on the evaporators to make sure there's no freezing or frost within the unit that can cause damage. Then the next section talks about shell and tube evaporators, and there are two kinds. There's a shell and tube evaporator with ammonia in the shell and with ammonia in the tubes, and it does have codes and recommendations for both. They're very similar, so we'll kind of cruise through the first one and touch on the second one. For the design, again, a lot of the same standards, minimum design pressure, pressure vessel requirements, and hydrostatic overpressure protection. In addition, you see the 1.1 times the design pressure, the subsequent leak testing, and the tight construction per design pressure. But in addition to that, for shell and tube evaporators, the code calls out that they must meet ASME, boil and pressure vessel code, first. So if the code is more conservative than the following design, the 1.1 times the design pressure code in this requirement, then you need to use the ASME code. So there's a little bit of nuance there as far as what should be used. Equipment ID is also very similar to the forced air evaporators we just talked about. There are the shell side and tube side maximum pressures and temperatures that are required, as well as some of the other items left out. So it's just important to remember that there are a little bit of differences, but a lot of this comes from the manufacturer directly. So there's not a lot of double checking on your part other than to make sure all the information you need is there. For the hydrostatic overpressure protection, again, it's required where the refrigerant coil inlet outlet connections can be automatically isolated. However, there is an exception. If the tube side of the evaporator is built and stamped in accordance with the ASME code, it shall be protected from overpressure in accordance with section 15.3. So 15.3 takes over if the ASME code is the governing code. If there's anything else being used or any other standards that are being used, then you revert to section 15.6. That is written in the codes. If you go there and look it up, it should say that right in that. Should say that in section 11.3.1.1. In addition, for equipment ID, the information provided, it does say it shall be provided by the manufacturers and should be in accordance with the UG section of the ASME code. The UG section, for anyone who may be wondering, is actually the number of the section. There's a section called UG. I have some details on that on a later slide and go over what actually is covered in that section. And going down to the bottom of the slide with installation considerations, it is the same as the ammonia in tube, so I'll talk about that on the next slide. So here we are with the ammonia in tube for the shell and tube evaporators. Again, the design information is very similar. It does add the tube side information from the ASME code, so that's important to note, as well as the overstatic pressure protection again is required where the tube side inlet outlet lines can be automatically isolated. So it's really restricting it to the tube side parts of the equipment. Again, there's an exception for if it meets the ASME code, then section 15.3 can be used rather than section 15.6. So there's a little bit of difference there. The procedures and testing, again, going back to the 1.1 times the design pressure, the leak testing, and the proven tight at design pressure. So there's no reference to the ASME code here. The equipment ID should again be provided by the manufacturers. This is actually stated in the code that they'll provide it and be relevant to the UG section. And at a minimum will include the manufacturer name, the tube and shell side information listed, serial number, year manufactured, and the test pressure. So it also requires one additional thing to the shell, the ammonia in the shell type evaporator. For installation considerations, again, this applies to the last type of shell and tube evaporator. The clearance shall be provided to accommodate maintenance and replacement of the evaporator tubes. Pretty simply put, but again, following manufacturer recommendations for clearances and requirements. The plate heat exchanger evaporators apply to a few different types, and I'll read it right from the code because it's a little complicated, and where it sounds complicated, I highly recommend if you have a plate heat exchanger to go and read the code and make sure that you know whether or not this would apply if you're purchasing something new, or perhaps if you're trying to upgrade your system and see a way to provide more safer operation. Equipment covered by this section includes plate heat exchanger evaporators of the plate and shell type, plate heat exchanger evaporators where the heat transfer plate stack is axially contained between two pressure plates and where the plate joints may be fully elastomeric. Paired plate sets that are welded with adjacent sets elastomeric, fully welded, or fully nickel brazed. Again, it's a mouthful. Please go read it if you have any questions on whether or not your heat exchanger or your evaporator may be applicable to this code. The manufacturer of the equipment should also know as well. As far as design information, the minimum design pressure, ultimate strength, pressure vessel information is all the same from the same sections. The ammonia side of the plate pack overpressure protection comes from section 15.3. We've talked about that before, some of the exceptions to the pressure vessel requirements, so that is being referenced here. And the non-refrigerant side is applicable to 15.6. Again, we'll talk about that in the next presentation of the series because that's the next chapter we're coming up on, but this is more for a reference. A lot of overpressure protection will be following in the next presentation. As far as hydrostatic overpressure goes, again, where the inlet and outlet can be isolated, there must be protection. However, the exception is if the evaporator is not a pressure vessel. It can be protected in accordance with 15.6. So there is another exception there. Again, it's in the code. Feel free to read it and refer to it as necessary. On the non-refrigerant side, the inlet and outlet lines of the plate packs, if they're isolated, must be protected. So that is something that calls out without an exception. And again, looking at the pressures, the procedures and testing section, the strength test, the leak testing, and the proven tight to design pressure are the same as some of the other pieces of equipment. For equipment ID, again, going back to what's required in the UG section, you also need the hot and cold side maximum allowable working pressure at specific temperatures. The UG section, I said before I go over what it covers, the UG section of the ASME code is the general requirements for all methods of construction and all materials. And this applies to boiler and pressure vessels, boilers and pressure vessels. This covers materials, design, opening and reinforcement, braced and stayed surfaces, fabrication, inspection and tests, marking and reports, and overpressure protection. So it does have a lot that it covers, applies to all vessels that are part of that code, and it's important to note that all that information is in that code. And again, that was the UG section, and then the installation considerations are based on the clearance provided by the manufacturer, and allowing for that the evaporator plates to be maintained and replaced as necessary. Scraped or swept surface heat exchangers. Again, the same design information. We're talking about design pressure, pressure vessel requirements, and the overpressure protection in 15.6. There is an exception to that overpressure protection where the heat exchanger is built to the ASME code. You can use 15.3. So again, like some of the other types of evaporators, we're going back to that exception of being able to use two different types or the two different sections depending on what kind of evaporator and the installation and setup and operation of that evaporator. The procedures and testing refer to ASME code first, and then at a minimum state that the 1.1 design pressure, the leak testing, and the tight construction are requirements at a minimum. For the equipment ID, again referring to all the information pertinent from the manufacturer. It does say that the manufacturer shall provide this information specifically for the scraped surface heat exchangers. And the different, couple different things that are added in here are the shell maximum allowable working temperature and the shell minimum metal temperature. In addition, clearance for the maintenance of equipment is called out in this section of the code. Jacketed tanks are the last type of evaporator we'll cover. Again, the design information and standards are the same as most of the other types of equipment. Does call out the ammonia side of the overpressure protection with an exception for the section 15.3 for the ASME code. If the jacketed tank evaporator is built to the ASME code, you can use 15.3 instead of 15.6. Again, the procedures and testing are in accordance with the ASME code or those minimum design requirements. So it's giving you a more conservative and less conservative view of what's required. And the equipment ID provided by the manufacturer includes the manufacturer name, of course, the maximum allowable working pressure, serial number, and year manufactured. Part of that is that this will all be in accordance with the UG section of the ASME code. And with that, move on to pressure vessels with Sara.
Good morning, everyone. My name is Sara Willman, and I will be covering chapters 12 through 14, which include pressure vessels, piping, and package systems and equipment. So we'll go ahead and jump right into chapter 12. Excuse me. So all pressure vessels shall comply with this chapter. And there's going to be a lot of similarities to things that Stephanie just covered with evaporators. For example, minimum pressure, which is covered in section 5.5. Section 5.5 discusses ammonia refrigeration system design pressure requirements. A minimum pressure is where ammonia liquid will be transferred from pressure vessels as pressurized ammonia gas. The pressure vessel design pressure shall accommodate the maximum possible transfer pressure and take into account the lowest possible coincident metal temperature. Design, fabrication, inspection, testing will all comply with ASME codes, and pressure relief connections for IDs greater than 6 inches and less than 10 feet cubed. Heads of pressure vessels shall be hot formed or stress relieved after cold forming. Vessels shall also be designed and stamped with the minimum design metal temperature, which is again the lowest expected operating temperature for the system. Section 12.3 covers procedures and testing and states that they shall be tested in accordance with ASME codes. 12.4 equipment ID is, again, of course, the manufacturers providing the data in accordance with relevant UG sections of ASME code. At a minimum, we'll cover similar things to evaporators, such as the manufacturer's name, the maximum allowable working pressure, minimum design metal temperature, serial number, etc. Specifically also for nameplate mounting, will comply with section 5.14.4, and if they are insulated, mounting on an approved standoff is required, or the insulation of the nameplate location shall be removable. So section 12.6 covers pressure vessel installation considerations, and the first section discusses access. Access refers to maintenance and repair access for the equipment and covers service provisions, testing, security, and isolation. Service provisions for testing of safety controls shall be provided, including shut-off valves and capped or plugged connection points. Serviceable equipment requires manual isolation valves, except for packaged systems and portions of built-up systems, which can have pump-down arrangements that provide for the removal or isolation of ammonia in lieu of isolation valves. The next section covers physical protection, which essentially talks about vehicle barriers being in accordance with the fire code. The last section of this talks about support. Support refers to the support and anchorage for refrigeration equipment and must take into account loading, seismic considerations, and vibration resistance. Moving on to Chapter 13, talk about piping. Section 13.1 talks about general design, fabrication, examination, and testing shall all, of course, comply with ASME B31.5 unless otherwise specified. ASME B31.5 applies to both shop fabricated and field fabricated piping and components. Section 13.2 covers piping, tubes, fittings, and flanges. Material will be covered in ASME code except for ASTM A53 type F pipe and cast iron. Those pipes shall not be used for pressure-containing sides of closed-circuit ammonia refrigeration systems. Also, zinc, copper, and copper alloys shall not be used in contact with ammonia. Section 13.2.2 says that the minimum pipe wall thickness shall be based on the properties of the selected pipe material. There are a few exceptions to this. Carbon and stainless steel threaded pipe shall be minimum Schedule 80 for all sizes. Carbon steel pipe less than 1.5 inches shall be a minimum Schedule 80, and stainless steel pipe less than 1.5 inches shall be a minimum Schedule 40. For tubing, wall thickness shall be based on the properties of the material and the grader of the design working pressure. So for pipe fittings, butt weld fittings shall match the pipe schedules. The exception to this is that the schedule of butt weld fittings joining the pipe at a wall thickness change shall match the schedule of the thicker wall pipe. The internal diameter at the end of the fitting connecting to the thinner wall pipe shall be machined or ground to match in accordance with ASME B31.5. All forged and cast steel socket weld and screw fittings shall be minimum class 3000 or ASME B16.11. Threaded joints shall also not be used for refrigerant piping larger than 2 inches in diameter. However, there's an exception to this for pressure relief devices and associated three-way valves. Pipe flanges shall be in accordance with ASME B16.5 and comply with ASME B31.5. Flange class shall be based on the design working pressure and maximum working temperature. The next section covers refrigerant valves and strainers. This section applies to both ammonia-containing and lubricant-containing service valves. Shutoff valve locations shall be installed at the following: inlet, outlet of positive displacement type compressor and compressor units, and the main feed inlets and outlets of individual refrigeration equipment loads, and the refrigerant inlet and outlet of pressure vessels containing liquid ammonia and having an internal gross volume of greater than 3 feet. Exceptions to this are valves within the ammonia-containing envelope of other equipment. For example, slide valves in screw compressors and safety relief valves. More exceptions to 13.3.1 are also package systems, as I mentioned earlier, and built-up systems can be permitted to have pump-down arrangements that permit the safe removal or isolation of ammonia for servicing in lieu of shut-off valves at each piece of serviceable equipment. Shut-off valves are also not required between a refrigeration equipment load and a pressure vessel containing liquid ammonia where a single load is piped into a single pressure vessel. For example, a surge bed evaporator piped into a surge drum. Package systems that incorporate subsystem isolation valves shall also not require more than one shutoff valve on each ammonia-containing pipe, connecting any two parts of the system. The next section covers valves and equipment and safety design. Where a required orientation of a valve is provided by the manufacturer, the system shall indicate the required orientation. These can include vertical, horizontal, or rotational orientations. Where a valve is deliberately specified for use with an indicator opposite the direction of flow, the system shall specify the intended installation direction. And valve gasket material shall be in accordance with the manufacturer's specifications. Next section is Chapter 13, Section 13.3.3, which talks about pressure relief being provided where a check valve is installed upstream of other automatic valves. There's a provision for liquid removal downstream of the check valve that was also required. And it's also important to take into consideration hydrostatic protection, which will be covered in a lot more detail in Chapter 15, which covers overpressure protection devices. Valve groups shall accommodate ammonia removal and facilitate strainer maintenance, and shutoff valves used to isolate equipment or devices from other portions of the system shall be capable of being locked out. Shutoff valves connecting ammonia-containing equipment to the atmosphere shall be capped, plugged, or locked closed during shipping, testing, operating, servicing, or in standby when not in use. And valves required for emergency shutdown shall be accessible and identified in accordance with earlier sections of the IIAR standard. For piping hangers and supports in isolation, it's pretty intuitive that they should be able to carry the weight of piping and any additional expected loads. Refrigerant piping shall also be isolated and supported to prevent damage from vibration, stress, corrosion, and physical impact. Threaded hot-rolled steel hanger rods shall be permitted, and anchors, their attachments, and methods shall be designed to support applied loads. Mechanically expanded concrete anchor bodies shall not be adjusted or axially spun after being set, and for insulated piping, support shall be designed or the insulation shall be selected to avoid damage to the insulation from compression. The location of refrigerant piping is very important for the safety of personnel and the public. We want to make sure that there's no piping in the way of anything where there's a lot of foot traffic. Refrigerant piping crossing walkway areas should always be greater than 7.25 feet above the floor. An exception to this is when piping is placed on a shorter room and they're on the ceiling. They should never obstruct any means of egress or evacuation route because it's very important that in the event of a release or an emergency, people are able to get out of the building without tripping on any equipment piping. They shall not be placed in any shaft containing moving objects such as an elevator shaft, a dumbwaiter, etc., or any other machinery room that is moving. They shall be permitted to be installed underground, provided that the piping is protected from corrosion. And if they are installed in concrete floors, they shall be encased in a pipe duct. So moving on to Chapter 14, we talk about package systems and equipment. For the general cause, packages shall be permitted to be enclosed or unenclosed and must comply with Section 5.16, which talks about equipment enclosures. They shall be designed, constructed, and installed in accordance with previous chapters of the IIAR, as applicable, and shall be ventilated based on the intended operation. Emergency mechanical ventilation shall be provided in the case of the following. Any package systems in machinery rooms shall follow requirements for the emergency ventilation of machinery rooms, which is Section 7.3.1. Any of them located indoors and outside machinery rooms shall also follow the same sections. Any package systems located outside that are designed for a human occupancy shall also follow Section 7.3.2. An exception to this is package systems located outside and not designated for human occupancy. Those won't require any ventilation since no one's going to be dealing with them too much. Equipment and devices incorporated into package systems shall also comply with Chapters 8 through 17 as applicable. So the design of package systems is very important. Structure shall be designed to support the operating weight of included equipment, and the structure shall be designed to withstand stresses caused by shipping, rigging, and operating. Temporary supports are permitted, and rigging instructions must always be provided, and they should be provided by the manufacturer. Structure of the package shall also be designed to withstand loads or stresses imposed after installation and startup. They should always have a valve pump out connection to remove ammonia. Also, going back to Section 14.2.3, they should be designed to withstand loads which include environmental factors such as snow, ice, wind, and seismic forces. and they should also be designed for use in the lowest and highest expected ambient temperatures of operation. Access to package systems shall be provided for manually operated valves. Isolation valves used for emergency shutdown procedures shall comply with section 6.3.3.1, which discusses that states that manually operated valves that are inaccessible from floor level shall be operable from portable platforms, fixed platforms, ladders, or chain operated. Pipes shall be marked in accordance with section 5.14.5, which discusses the requirements for pipe markings. One namely very important is that they should all say in capital letters a big ammonia on the side of them. The next section discusses equipment that shall be labeled in accordance with the same chapter, and they shall also be equipped with lighting, or the area with refrigeration equipment shall be equipped with light fixtures which deliver a minimum of 30-foot candles at the working level. Enclosed packages that require entrance for service, maintenance, inspection, or operation shall have lighting control located at the entrance. An exception to this is where continuous lighting exists. The lighting control is not required at the entrances. So for fabrication of package systems, equipment shall be set on the package in accordance with the manufacturer's recommendations and shall be supported to withstand transporting and rigging. Stationary or temporary rigging points shall be provided as required to position the package, and piping shall be pressure tested after fabrication and leaks shall be repaired. It's important to note that packages shall be shipped with a holding charge of dry nitrogen or provided with another means approved by the manufacturer to allow validation that leakage has not occurred during the shipping or subsequent storage prior to installation. Electrical equipment shall be installed in accordance with electrical code, and gas-fueled devices and equipment shall be installed with respect to the mechanical code. Next, we'll talk about alarms and detection. Detection alarms for package systems shall comply with the following information. If they're located in machinery rooms, they shall be included as machinery room equipment and comply with section 6.13. Section 6.13 discusses ammonia detection and alarms and states that a detector shall activate an alarm that reports to a monitored location, and audible and visible alarms should activate. If they are located indoors and outside the machinery room, they shall be provided with level 2 detection and alarms in accordance with section 17.7.2, which is covered in chapter 17, ammonia detection and alarms, and will be discussed in more detail in the next IIAR segment. If the equipment is located outdoors and not intended for human occupancy, it will not require any ammonia detection or alarms. So with that, in our next segment, we will be covering chapters 15 through 17 and an appendix overview, which includes overpressure protection devices, instrumentation and controls, and ammonia detection and alarms. Also, we have several important webinars coming up that will be useful to you. Specifically on June 1st, we'll be discussing DHS CFATS regulations and how to prepare for an audit. And not long after that, we will be discussing how to use HAZOP and LOPA to create an effective mechanical integrity program. Thank you so much for your attention. And with that, we'll bring Stephanie back over here and take questions.
So we have two questions from the audience. The first question is, there seems to be a lot of information required for equipment ID. Why is that information so important?
Okay, so the question was, why is equipment ID so important and why is it required for each piece of equipment? One of the biggest reasons would probably be because eventually those nameplates will be faded, worn, perhaps damaged, and in the meantime of ordering a nameplate from the manufacturer and getting a certified nameplate for that piece of equipment, it's helpful to have that information in a secondary place. In addition, especially with new equipment, it's your opportunity to record that information so that if you do lose a nameplate, perhaps it gets covered up by something, or it's just easier to access it in an office setting versus going down to the equipment. You'll have that in an area or in a location that you can easily get to and look at. You can also compare equipment within your system pretty quickly if you have it all in one place.
The second question from the audience. In the presentation, built-up systems were mentioned. Can you elaborate on the difference between a built-up system and a package system?
So to repeat the question, it is asking us to elaborate on kind of specifically what a built-up system is versus packaged. Kind of by the name, you can tell a package system essentially comes as a full package from the manufacturer and can be installed directly as it is. And a built-up system, essentially, you get the pieces and you install it piece by piece. And this is important to note because if you go into facilities, sometimes the older compressors may be more of a built-up nature and have separate valves that will be installed, and newer compressors may come as a full package.
Another question from the audience. Are condenser units considered package systems, and do they require ammonia detection?
I have to go back and look at the condenser section because that was covered, I believe, in the last part of the series. But the ammonia detection applies to inside the building and the occupancy on which it's rated for. If it's outdoors, I believe there are some other stipulations on what's required, and I would just have to look up exactly what those requirements state for if it's specific for condensers or if there's a general statement for detection that would apply. We have the email address? Yeah? Okay. Yeah, I'll get back to you in email right after the presentation when I can look at the last part of our presentation and get a better answer for you. Okay, looks like we're done with questions. Oh, more coming in? No? Okay. All right. So the audio and PowerPoint presentation will be available within the week. We usually get it up sooner, but we give us a week to get that up and running on our website. In the meantime, if you have any questions, our emails are available, and we can be reached at any of the contact information listed on the slides.
Thank you.